Earth has a second moon. Most people have never heard of it, and the reason it stayed hidden for so long is that it doesn't behave like a moon at all. It's small, somewhere between the size of a Ferris wheel and a city block. It loops around us in a strange, wobbling dance, staying close to Earth for centuries at a time. And in 2021, when scientists finally analysed what it's made of, they got an answer nobody was prepared for. It isn't made of asteroid rock, it's made of the same material as the moon, the one you already know. And here's why this matters right now. As you watch this, a spacecraft is making its final approach to that second moon. In July, it will pull within 20 kilometers of the surface, close enough to grab a piece of it and bring it home. We're about to find out exactly what it is. Its name is Kamoʻoalewa, a Hawaiian word that roughly means the oscillating fragment. And the first thing you need to understand is why calling it a second moon is both true and not quite true. Our moon orbits the Earth. Kamooalewa doesn't. Not exactly. It orbits the Sun on a path almost identical to Earth's, so closely matched that from our point of view, it appears to circle us, looping ahead and behind and around our planet year after year. Astronomers call this a quasi-satellite, a companion that travels with us without ever being truly held by us. And it's a faithful companion. While most objects that drift near Earth stay for a few months and leave, Kamooalewa has been with us for a very long time, and the math says it will keep pace with Earth for roughly another 300 years before slipping away. It was only discovered in 2016 by a telescope in Hawaii, because it's so small and so faint that it had hidden in plain sight the entire time. At its closest, it still stays about 14 million kilometers away, far too distant to ever see without a serious telescope. So we had a tiny, loyal companion we'd never noticed. The obvious next question was the simple one: what is it made of? And the answer is where this stops being a story about an asteroid. In 2021, a team using 2 large telescopes in Arizona did something simple but decisive. They measured the light reflecting off Kamooalewa and broke it down into its spectrum, the chemical fingerprint of a surface. They expected it to look like an asteroid. It didn't. The spectrum didn't match any known type of near-Earth asteroid. What it matched, almost exactly, was lunar rock. Specifically, weathered material brought back from the moon by the Apollo 14 astronauts in 1971. Let that sit for a second. A small body, quietly trailing Earth around the Sun, made of the same stuff as the moon. There was a second clue too. When asteroids drift past Earth, they tend to do it fast, on average around 20 kilometers per second. Kamooalewa creeps past at just 2 to 5. That's the speed you'd expect from something that didn't come from the distant asteroid belt, but from much, much closer to home. Quick one, while that sinks in, drop a comment. Did you even know Earth had a second moon before this video? Yes or no? I'm genuinely curious how many people have heard of this one. Now, if Kamooalewa is made of moon, the question becomes almost unbelievable. How does a piece of the moon end up orbiting the Sun next to us? So, picture this. Somewhere in the last few million years, an asteroid slams into the far side of the moon, the side that never faces Earth. The impact carves out a crater 22 kilometers wide and flings a chunk of the moon's crust off the surface so violently that it doesn't fall back. It escapes the moon entirely, and it drifts into an orbit around the Sun that keeps perfect pace with Earth. That chunk becomes the silent companion we wouldn't notice for millions of years until a telescope in Hawaii finally catches it in 2016. That's the leading theory for what Kamooalewa is, and it's not a guess pulled from nowhere. Scientists think they've found the exact crater. The crater is called Giordano Bruno, and the reason it's the prime suspect is its age. Most craters on the moon are billions of years old. Giordano Bruno is freshly made, somewhere between 1 and 10 million years old. Recent enough that the debris it threw out could still be traveling alongside us right now. But how do we connect a crater on the moon to a rock millions of kilometers away? That took two separate pieces of evidence, and they arrived years apart. The first came in 2023. Researchers ran detailed simulations of what happens to material blasted off the moon and found that under the right conditions, a fragment could settle into exactly the kind of Earth-trailing quasi-satellite orbit Kamooalewa sits in today. The pathway was possible. The second came in 2024 in a study published in Nature Astronomy. They took it further, matching Kamooalewa's specific orbit and spin back to Giordano Bruno itself. Two independent lines of evidence years apart, pointing at the same crater. It's a beautiful story. There's just one problem. Not everyone is convinced it's true. And in early 2026, a new study came out that argues the whole thing might be wrong. Genuine question before we get to that. If it really is a piece of the moon, that means there could be other lunar fragments out there we haven't found yet. How many hidden moons do you think Earth actually has? Drop a number in the comments. Here's where it stops being a settled story and becomes a live scientific argument, one that's going to be answered for real within the next 2 years. Because we're not just debating this from telescopes anymore, we're going to go get a piece of it. In May 2025, China launched a mission called Tianwen-2. Its target is Kamooalewa, not to fly past it, to catch up with it, orbit it, and physically collect a sample from its surface. And as of this month, it's in the final stretch. In early June 2026, the spacecraft fired its main engine and began its approach phase, firing tiny ion engine corrections to slow down, because Kamooalewa's gravity is so weak that a single hard burn could throw the spacecraft off course entirely. The plan is to settle into position about 20 kilometers above the surface in July, map the whole object with 11 instruments, then descend, grab at least 100 grams of it, and fly it back to Earth, with the capsule landing in Inner Mongolia around 2027. Think about what that means. For the first time, we won't be guessing from reflected light. We'll have the actual material in a laboratory. If it's lunar rock, billions of years old, formed under conditions that no longer exist on the moon's surface, we'll know. And if it's ordinary asteroid rock, we'll know that too. Because in January 2026, a separate team published an analysis that pushed back on the entire lunar origin idea. Their argument was statistical. They modeled how many Kamooalewa-like objects you'd expect to find if they came from the ordinary asteroid belt between Mars and Jupiter, and how many you'd expect from lunar impacts like Giordano Bruno. Their conclusion: the asteroid belt should produce far more of these objects than the moon ever could. By their numbers, the odds favor an ordinary asteroid origin after all. It doesn't disprove the lunar idea. The spectrum still looks like the moon, but it means the case isn't closed, and two groups of serious scientists are now looking at the same small object and reaching opposite conclusions. And this is what makes Kamooalewa different from most space mysteries. Usually, when scientists disagree about something millions of kilometers away, the argument can run for decades with no way to settle it. Not here. The James Webb Telescope already turned its instruments on Kamooalewa in early 2026 for a closer spectral look. and Tianwen-2 will put the actual rock in human hands by 2027. Within roughly 2 years, one of these two camps is going to be right and the other is going to be wrong, and we'll have the physical proof to say which. It's rare to catch a genuine scientific mystery in the exact window before it's solved. We're in that window right now. Step back for a moment because either answer is staggering. If Kamooalewa really is a piece of the moon, then for millions of years we've had a fragment of our own moon quietly following us around the sun, unnoticed until 9 years ago. And if it's just an asteroid, that's almost stranger. It means the space right around Earth, the neighborhood we think of as empty, is quietly full of companions we're only beginning to count. Either way, the lesson is the same. We assume we know our own backyard, and then a telescope in Hawaii finds a second moon we never knew we had, and we realize we'd been sharing our orbit with it the whole time. The question was never whether the universe is strange far away. It's how much of the strangeness has been right next to us all along, waiting for someone to finally look. Subscribe to be here when Tianwen-2 brings the sample home in 2027 and we finally know what it is. And the Sedna video is up next. The planet at the edge of the solar system whose orbit shouldn't be possible. It's already up.